Alright, we are back for our second video. Alright, we just talked about direction, right? So describing scatter plots, we've talked about direction, positive, negative, no association. Now we're going to talk about form. Alright, form's going to take you back to algebra. Alright, so you've either got two options, a linear form or a nonlinear form, right? So the pattern of dots could either show a straight line or it could not show a straight line. So looking at these examples, this right here roughly shows a straight line, right? So this example is linear. Here, this again, if I could draw, it would be a line, linear. Now here, this does not look like a line, right? It looks like a curved pattern. So we're going to call that nonlinear. And again here, nonlinear. Now, I know you're really impressing me at home, right? You're yelling exponential and quadratic from Algebra 1. I can hear it. Y'all are so smart. But for statistics, right now, we just need linear or nonlinear. That's it. You don't need to tell me what form this is. It's either a line or it's not a line. Easiest math class ever. All right, flip the page over. All right, so we've gotten direction and form. Now we're on strength. So we've either got a weak association, a moderate association, or a strong association. And again, we can use the words roughly to describe all these things because it's never going to be exact, right? So, strong positive. Do you see the closer the dots are together, the stronger relationship they are? They look more like a line, right? So here's a strong positive and here's a strong negative. Now we know this is positive because we're reading it like a book from left to right and it's going up, just like a positive slope would in algebra. Here it's a negative correlation because from left to right it's going down. So strong positive, strong negative, the dots are more close together. Moderate positive, it's going up from left to right and the dots are a little bit further apart. Same with moderate negative, it's going down and the dots are a little bit further apart. Now weak, I can still definitely see the linear pattern, right? And it's going up from left to right, but the dots are just pretty far apart at this point. So strong, moderate, weak, strong, moderate, weak. So the words that describe strength here are strong, moderate, and weak. What do these describe, the positive and the negative? Those describe direction. And then what form do all these take? They are all linear. All right, so you've got all three words so far, right? We've got direction, we've got form, and we've got strength. Our last thing that we need to describe is unusual features. So outliers or clusters. And so when we actually mention them, we need to mention where they are on the scatter plot, right? So this one right here shows our outlier. All right, we have an outlier at about, this is per 100, so I would say maybe $20, what does that say? Carry rate? Cane rate? What? I don't know, whatever that is. You would say you have an outlier approximately here and here. Cavity maybe? Cavity and fluoride? I don't know, I can't read that small. All right, here we've got two clusters. So I would say I have one cluster at around 2 minutes and 55 minutes, and then another cluster at around 4.5 minutes and 80 minutes. This is Old Faithful eruptions. We'll come back to this because we're actually going to describe this graph later by the end of the packet. All right, so we've gotten all four things that we need to describe, right? Number 1, direction. Number 2, form. Number 3, strength. And then number 4, unusual features. And remember, if there are no unusual features in our scatter plot, let's explicitly state it to make sure that we get any and all points on our free response. So we would actually say there are no unusual features. All right. All right, back to the direction. Our positive association, our negative association, and our no association. So we talked about what directions each variable would go, And now let's look at it in combination with the scatter plot, right? So with positive, we're just going the same direction. With negative, we're going opposite directions. And with no association, there is absolutely no association, right? So here, positive, as this goes up, so does as the explanatory goes up. Explanatory, then the response also goes up, right? As the explanatory goes down, the response also goes down. It's the same direction. Now here, it's negative. Do you see as my explanatory variable gets bigger, my response variable is getting smaller on the y-axis? So like this point right here, my explanatory variable is very high, but my response variable is very low. So we're going opposite directions, right? Positive is same direction for both variables. A negative relationship is different directions. And then no correlation would be some sort of random scatter plot. All right, flip the page over. We are on the last page. All right. Now, something important to know. Even when there is a clear relationship between two variables in a scatter plot, the direction of the association describes only the overall trend, not an absolute relationship. Not an absolute relationship. So that's just our statistical qualifier that we do with everything, right? We always say things are roughly, or they're about, or they're approximately. We're just describing the overall trend. We are not saying that there's an absolute relationship between these two values. At some point in statistics, we can prove an absolute relationship, but this unit is not that unit. So we are only describing the overall trend of the data and not an absolute relationship. Okay, we're going to put it all together here with our describing scatter plot sentence stems, and then we'll have two examples to describe the scatter plots. All right, remember to use context when describing scatter plots. So context includes both variable names in the description. That's the easiest free response point we can get. We always need to use context. All right, so the four things that we need to describe: direction, and my options there, positive or negative. Form, my options there are linear and nonlinear. Strength, my options are strong, moderate, and weak. And unusual features. Typically it would be an outlier or a cluster or nothing at all. All right, so here are our different sentence stems. Remember, we have to use context when describing, right? So number one, there is a, and we would choose one, strong, moderate, weak, comma, positive or negative, comma, linear or nonlinear relationship between the explanatory variable and the response variable. So do you see we bolded and underlined everything that you need to update in the sentence stem, right? So you choose one of these three, choose one of these two, choose one of these two, and we fill in the actual names of the explanatory and response variable. Remember, on the scatter plot, the explanatory variable will always be the x value, and the response value will always be the y value. All right, you could also say there is no relationship between the explanatory and the response variable, right? And you would see that with a scatter plot with random dots, right, when there's no relationship. So you would either do number one or number two. Now, number three, this is a potential outlier. There is a potential outlier, and again, we say potential because we have not done the outlier test, right? So there's a potential outlier with an explanatory variable value of x and a response value of y. So that just tells the person reading your sentence where the outlier is. And then if we have clusters, we say there are how many clusters? One main cluster, two main clusters of points around, and you say exactly where the clusters are in a scatter plot. All right. So I will do number 4. You can pause the video if you want to go ahead and try it, or you can follow along with me on number 4 and then pause the video and try number 5. All right, so describe the following scatter plot. All right, so looking at this, we definitely want to use number 1, right? Because there is a relationship here, right? You see the relationship? All right, so let's use sentence stem number 1. There is a... All right, what would we call this? I would call it moderate. You could call it moderately strong. Again, if you use a qualifier, I would say strong or moderate would be accepted, weak would not. So there is a moderate, comma. Now, is this positive or negative? From left to right, it's going up, right? From left to right, it's going up, so that's a positive. There's a moderate, positive, and then this form is linear, right? It's not nonlinear. All right, so I've chosen my strength, my direction, and my form. There is a moderate, positive, linear relationship between average daily temperature and number of beach visitors. All right. So we're not going to use number 2, right? Because we said there is a relationship. All right, do we need to use number 3 or number 4? I don't really see any clusters. Now, you could say that there's a potential outlier right here, right? You could also say there are no potential outliers. I would say that this is close enough to the form. But let's go ahead and name it just because we're using the word potential, right? So we're not actually stating that it's an outlier. We're saying it could be. And outliers with respect to scatter plots are just dots that are away from the pattern, right? So when we look back over here, we had this dot that was away from the pattern. So let's say there is a potential outlier with an average daily temperature, and that would be about, let's see, average daily temperature of 87 degrees Fahrenheit, because that's my unit, right? And we go over here, about 100 beach visitors. Now, if you were to say that that was not an outlier, if you deemed that part of the pattern, you would say there is no potential outliers or unusual features of the scatter plot. All right. So go ahead, pause the video, try number 5, and then come back when you're ready. All right, number 5. The scatter plot below shows the relationship between the duration in minutes of an eruption and the interval of time until the next eruption of Old Faithful during a particular month. Describe the relationship in context. Okay, so between 1 and 2, between a relationship or not a relationship, there's definitely a relationship, right? So we would say there is, I would describe this as pretty strong. You could say there is a moderately strong, positive, linear relationship between the duration in minutes of an eruption and the interval of time until the next